Okay, folks. This part of the presentation, I'm going to bring you off on a little bit of a tangential journey. The presentation I'm going to show you now is the presentation I did at the Manufacturing and Supply Chain Conference and Exhibition in CityWest. It's going on 3 years now. I've been there a couple of times making presentations, and this was the last time I did. And they asked me to choose a subject of that interested me, and of course I chose big data and its benefits to supply chain management, and technically what could the impacts be. So with that, let me get down to the lecturing area and we make a start on this. And here we have the slides coming out, and we'll enlarge them. So where am I? And here we have CityWest. So I've slightly modified them because I'm using a slightly different explanatory analogy. But let's have a look. So basically we're looking at big data and supply chain management, and where is this all going? Well, if we look here, and what does the data mean? And guess what? Being at one of the last presentations we're doing, I'm not going to miss the opportunity to bring in the bike or cycling. So if you think back, bear with me, because it is a good analogy as it happens. If you look at the older traditional bikes, back in the days of Stephen Roach or Sean Kelly and so on, so that's the kind of machine they were cycling. And you could come forward a couple of years and you can stick a digital head unit, as we call them, or computer onto it, and you can track your time on it, or how long you spent out cycling and the speed you're doing. Now come up a little bit more to today's levels, and you begin to look at these more higher end bikes, carbon fiber and all that sort of stuff, lightweight. And now the machines themselves have become extremely sophisticated. And if you take this one here on the bottom left one, or bottom right one, I mean, you wouldn't see much change out of 700 or 800 euros just for that machine itself. It's almost the size of a mobile phone. But even if you look into it, you can see things inside here, graphs of it'll track the gradient of the road or the hill or the mountain that you're cycling, and your duration and so on. But it has a hell of a lot more data inside there. And why? Because we have sensors built in to, could be inside in the cranks, as we call them here, or in the pedals themselves. We'll definitely have calculating the power. You'll have speed, you'll have the rotation, which is the cadence, the speed at which you go. You'll probably wear a heart monitor, or you could use your Fitbit as such. What else? Oh, and the newer piece of technology that they're using is another strap on which measures your core temperature, your internal core temperature, from the a strap on the outside. So you have basically 1, 2, 3, 4. Generally, for most of us commoners, 4 sensors tracking data. But this is where it becomes really interesting. The amount of information that we can get from the raw data is just phenomenal. And I just took a couple of examples here by way of the definition. This is one of the post-analysis site that I'd use. It's called Velan Viewer. So all the data that is stored in my computer is uploaded the minute I come back to my Wi-Fi area. It's automatically uploaded once I stop the spin, and it starts to pull out this. So if you take, for example, down here, it was a morning ride that I had taken, and you can delve into it. And here's the profile of it. It maps out. It used geoanalytics to precisely map where you were, the terrain that you're in, and then you have all of these different sensors: speed, cadence, power, heart rate. Let's go on. There's a couple more of them, and different versions of the graphs. Excuse me, sorry. versions of the graphs that we can actually track the data on. And here again, using the same raw data overlaid onto an actual map of the route of the spin itself. And here's what we call a heat map of the number of times. So you can see the cooler ones, less visited sections of where my location, and then the more as you come in more here, the more frequently I would have used particular sections of road and so on. So I can get a heat sensor over since in this case, since I started recording the 2 years. So essentially what I'm saying here is that in our business world, we're using systems like SAP and Oracle and so on and so on. And these, as we say, might be legacy systems, what we have in place. Now we need to augment them with far more sophisticated systems that sit on top of the raw data. So if you think back from one of our earlier presentations from memory, we talk about data, information, knowledge, and then experience. Okay, or experience and then knowledge. That's the hierarchy of how we gather stuff and make sense of the world around us. So you have data, information. So if you take two pieces of data, multiply them together, add them, divide them, subtract them, you begin to get information, ratios, for example, and augment a couple of ratios, you get additional information. So we begin to layer different pieces of ratio and results, and we layer the information and layer it and layer it and layer it, and we begin to get more experience at doing it more efficiently, better processes, improved processes, and ultimately we end up with knowledge, and that knowledge is constantly being refined based on the data and the expansion of data. And that's essentially, so if we look at a definition of big data, so extremely large data sets that may be analyzed computationally to reveal patterns, trends, and associations, especially relating to human behavior and interactions. Okay, so whatever types of data that we can pick up on in terms of the way we do things. So it's not just what we do, but also the way we do. And here was a prediction, and as far as I know, we've actually gone way beyond that. We're probably somewhere in the region of 18, 19 trillion gigabits of data, useful data. Okay, clearly, and one of the biggest contributors to the growth of that has been this past bloody year of COVID and so on, because more and more people were going online, and we've gathered phenomenal data about behaviors and purchasing trends and so on. And in the other video, the other part of the lecture earlier on, you will have seen the video in relation to the supply chains and shipping and so on. But anyway, so from enterprise resource planning systems, mobile and e-commerce capabilities, or digital marketing, to systems driven by artificial intelligence, the machine learning businesses cannot expect to be or remain competitive without investment in technology that enables data analytics. And if you haven't got a website and you're not using the data that you're trapping on your website, then you're pretty much in the dark ages, and it's only a matter of time when you will go out of business, because you won't have the data, you won't be able to collect sufficient data or information to make really important decisions about the way your organization should be going, and responsiveness and so on and so on. And the more data you have, the better the information, and the better the information, the more you're knowledgeable of the environment within which you're operating. So here's just some of the should we say the pathway of gathering data and so on. How do we trap it? And remember, I mentioned there those various sensors inside in bicycles. That's the acquisition. Your EPOS systems, your scanners, your code scanners, your barcode scanners, your RFID technology, and so on and so on. All of these types of raw data collectors. Even humans, by counting elements in stock or items in stock and so on, and manually putting in. It's a form. It's still being used clearly, but it's a way of collecting or acquiring data. And as you see, we have protocols, data streams, multimodality, different ways of collecting different types of information, RFIDs, code scanners, for example, different modalities. Events processing, what happened at a particular point in time. How long does it take for a product to get from this workstation to the next station? That's an event, and the processing that takes place in that, so we can time overall the throughput of that particular process or the event as such. And then we do the analysis, the data analysis. So we stream semantic analysis, machine learning, so the machines can work at a pace. So again, looking at the rate at which a machine is operating, and if you can identify potential bottlenecks, then it can slow down as such. It's like your accelerator in your car, you can see speed limits, so you put ease back, so you get machines can behave like that similarly. Information extracted, linked data from different sources. Inside in the organization, so you can link data from earlier parts of the process, can give you a heads up of something coming. Therefore, we need to clear down the existing process and start from a scratch process and so on, or have a clean plate, so to use that expression, just so as we can evaluate how we're throughputting stuff in that later process, for example. And ecosystems, again, how would I best describe ecosystems? You could take your a whole production line of one particular product could be considered to be an ecosystem in its own right. And then you have different ecosystems or product lines. So are there things we can learn from one product line that can be implemented in another product line? So cross-population of knowledge. So, and then cross-sectoral data analysis. So looking at what happens in one particular side in the industry, and how does that affect another industry, another sector in the industry. So for example, you have the whole transportation issues today. Sea transportation and so on, all the issues around the Suez Canal and all that. So how did that affect, or could it affect, the retail industry? And quite clearly, and negatively. And also, more importantly, COVID. How is that affecting the retail industry? The knock-on effects of this in that previous video does a pretty good job. The video from Wall Street Journal does a really good job on describing the knock-on effects from the bottlenecks that are arising in these long supply chains, as we refer to them. And then, of course, data curation, the quality and how are we assessing the data, is are there bits or elements or variables missing in the data, for example, top-down, bottom-up approaches. So this is what we think we have, and now we calculate on do we arrive at the same conclusion or the same set of data. I would say human computation, okay, that's straightforward. Curation of scales in terms of trends and whether it is a linear trend or exponential and so on. And interoperability, can you use the data from one set, can it be applied in another environment? So take, for example, if you're using a power meter to gauge the power coming down, can we also calculate the cadence based on the gearing that you'd have? So we'd have different uses of the same data. The power then can calculate out the pressure you might be putting on your heart, for example, in using the biking analogy. And the rest of the data storage, that's predominantly the systems that we use to store, whether it's an in-memory database, SQL databases, scalability and performance of data sets and data modes or databases, fundamentally computer systems where we store the raw data. And then finally, the data usage, precision support, prediction, in-use analytics. So can we do things when we begin to see trends? Can we adjust? It's like driving a car. If you see something down the road, then you adjust. You don't keep going at the same speed. You'll ease up probably if you see there's a blockage and so on. So we're taking that type of in-use analytics. We can gauge our speeds and so on. It's the same thing inside in business. If we can see that the retail sector or one particular retail outlet is how to say, running into trouble, then we may cut back on production until we find alternative retailers, or if we can get the other existing retailers to up their throughput to take up the slack of what we would have been selling to an original retailer that's running into a spot of bother, should we say. And then, of course, modelling and control and domain-specific usage. So data modelling, right in the thick of NEFIT. It had to come up sooner or later. But again, the reprofiling, the words and expressions that have been made up this last year are just something else. But the reprofiling, and so what was it we heard today, was it 83 or 89 times they had to readjust based on the supply chain and so on, and that's based on the data that's available to them and predictability and guaranteed supply of the various vaccines and so on. So it's all about scenario testing and the what if. What if this happens, or what if that happens? So it's for all intents and purposes, they're just like very, very complex spreadsheets. But you're running these algorithms and you have programs to do that more efficiently. But in more advanced systems in business, and so the systems themselves can learn based on performance and having identified trends and behaviors in certain supply chain. It can adjust automatically for you. Okay, so moving on, if we look at as I said, the big data value chain. Now, the kinds of things that we need to look at in terms of the skills and that might be required. So we look at here, if we start up at the top, or on the top right here, ownership, copyright, liability, and then solvency and privacy in terms of who owns the data, how it's being used, can you share the data, accessibility to interworking systems and so on. So you have the whole legal entity of that end of it. Moving on to the social side, user behavior, societal impact, and collaborations. So again, Pete Lund is a great man, and I enjoy listening to him talk. But he's a behavioural economist. Again, looking at human behaviour. Why do people behave in certain ways? How do they react to various stimuli and so on? And the same thing applies here when we're looking at. And we need to be able to gather the data, and that's where we use video technology, for example, to try and extract more and more data rather than just simply questionnaires. But if we watch behaviours and watch groups of behaviours, then we can see clusters of things happening around, like something like the heat map that I showed you earlier on, going from blue to green and yellow and then red, so you can spot clusters, and that's precisely what they would have been doing with some of this COVID tracing and tracking and identifying the clusters, where the hotspots around the country and so on. And if they begin to see a move towards yellow, then they can predict that this could potentially be a hotspot in that particular town or county and so on. Then the business models, from the economic perspective, benchmarking, open source development models, and information pricing. So based on the previous behaviors, for example, then we can predict the responsiveness to a change in price. Your basic economics, such as elasticity of price and elasticity of demand, for example. But now we build our models, so we can slightly tweak and then predict performance and behaviors of people, and therefore influence those. How? Through the technology side, and on the next segment, through the likes of social media. And if you look at it here, scalable data processing, real-time statistics, machine learning, linguistics, and human-computer interface and visualizations. So we can get all of this other information and try to make sense of it. And that's why we need the technology to represent such vast arrays of data and the complexity of the data, and try and get it into such a state that our minds can get our heads around what we're looking at. And then, of course, the application, then data-driven decision making, risk management, competitive intelligence, digital humanities, Internet of Things, verticals, and Industry 4.0 in terms of the technology we're looking at, and so on. So these are it's all gearing towards the amalgam of all of these elements. Even itself begins to convey the complexity of getting good information to enable us to know what to do, what decisions we can take, and how quickly we can assimilate that data and that knowledge and make our information and make effective decisions, and how quickly we can change our minds. And that's the whole point, or the whole ethos behind agility and responsiveness. So if we're moving on, there's not much more to go on this, so you'll be delighted to know. So business models are based on rapid product life cycles, and of course speed, and that's where we look at increasingly demanding customers' expectations. Building better collaborations using big data underpinning more complex supplier networks, focusing on knowledge sharing. And this is the whole point about the partnerships and the four PLs and five PLs, logistics service providers, third party and fourth party, is the whole area of collaboration and sharing the knowledge. That's critical. I mean, there's none of this as we used to be in school. You're not going looking at my marks and my answers. No, we have to be more open. And in some industries, particularly in the computing and automotive industry, and a number of the financial services, how they share and open up information. Again, it's all highly protected and copyright and legal issues around it and so on and so forth, but they willingly share information and knowledge to enable them to be more effective at doing what they're already doing. And then, of course, the whole point of forecasting. Integrating big data and data analytics into optimization tools, demand forecasting, supplier collaboration, knowledge sharing, and business planning supported by artificial intelligence. Now, what can I say about this other than have a look at the Otto case study? It is already uploaded, but it's a superb example of how you can use a non-related industry such as the physics, experimental physics area of CERN, how they used a small part of that experiment to build an AI system to serve an online product company, in this case Otto, and how it improved the way it was already doing stuff, reanalyzing information and data that was already in their system and extracting new information, better information, and enabling better decision making, which tremendously improved reverse logistics issues in that same company. And that's only one part of it. And another one of the goals are byproducts of the technology was their way of predicting what customers could potentially be buying before the customers actually buy it themselves. I know it sounds far-fetched, but that's where they're already at. Again, why? Because they're able to look at trends and behaviors, and that's the key to it. Stuff that we would have thought was immeasurable is now extremely measurable, and therefore we can see and we can predict. And don't forget, you also have Alexa and Google having a good listen to you every so often, and then you see stuff coming up on your mobile phones or on your web pages on hits like that, so you're wondering why this information. So it's already profiling, and they're sending stuff back to you because of the sites you looked at, because of what you've said, and so on. Geez, remarkable. And it does happen, unless you turn on your privacy settings, of course, or turn off the microphone. And then use of geosystems and geoanalytics to optimize network delivery. Again, looking at live traffic data, for example, looking at planning offices, for example, road construction, and so looking at all of these what might appear on the surface from a transportation organization, stuff that, or is there a planned demonstration? Is there a planned, is there something that is there a holiday coming up? So taking into account all of these things that oftentimes we might simply overlook or totally forget about, and the systems will help to optimize based on this in a real-time basis. So as we're getting towards the end of this, so what are the benefits? So leading to fourfold improvements in order cycle times in operations when intelligently applied. So when you're measuring the right data, you will then optimize your order cycles, because you know where to hone in and where to what data you need, and you're becoming more and more efficient about what you're collecting and how you're collecting and how you're actually using it. So big data visibility linked to financial systems effectively show how supply chain strategies and operations influence financial objectives. So when you have all of these systems extremely well integrated, and we're talking about layered versions of SAP, to use an expression, so along the complete supply chain you have your SAP systems talking to one another, and therefore you can create higher levels of metadata, and you can actually test those without actually implementing them to see what are the financial benefits or not of doing changing, tweaking a process here, or improving or changing or replacing or removing a particular process or part of the supply chain itself. And of course, one of our favorite topics that has arisen is this whole area of reverse logistics. As I call it, it's a minefield, and it is. And big data can improve traceability, performance, and so for example, managing recalled and retrofitted products and so on. So getting better usage. I was listening today on they were talking on the radio about electronic items and insurance and so on, and there was one interesting one where someone had, I think it was an iPhone or whatever, and they under the insurance it was they could have it replaced. It was broken, obviously, but what they got back was a second-hand one, and they weren't too happy about that. So it all came down to the terms and conditions. Was this explained? Some insurance policies have new for old, so if it's your old TV that still fell on the ground, they'll give you a new one regardless, but you're probably going to be paying for these. But do you honestly think that they're doing that out of the goodness of their heart, or for purely just for customer sentiment and retaining customers? Not necessarily. It's because they know they can calculate out, and I think I told you before that the whole idea of insurance when you buy your Dell products, and why? Because the guy that set it up was a good friend of mine many years ago. We were talking about the 2001 2002 time frame. He was setting up their reverse logistics and support system, and they already knew. They knew based on the performance and the data that they had collected, the propensity for various components to fail, and roughly when they were going to fail. So they knew what to keep in stock. So straight away they didn't have to overspend in stock. They immediately knew that they only needed certain elements that had the fail factor inside, built into them. I won't say fail factor built in, but their vulnerability of to failing. So they knew precisely what, and yet they were able to get people, and again, human behaviour. People want to have the comfort of knowing that, yes, it can be fixed within 3 hours or within 2 days. I'll spend the extra money and so on. As he said to me, money for old rope, and he was right. And these are the last two companies, Amazon Go, for example, and Otto. And even by 2020, we said 16 now I'm pretty sure we're close on the 19, 20 zettabytes, or trillions of gigabits of useful data. Now, as I say, what's useful and what's not useful, that's another debate. It's is data in the electronics manufacturing industry useless to the automotive industry? Well, logically you wouldn't say, well, they're two different industries, but no, they're not, because they would have similar components, for example. So how performance and expected growth in one particular industry can negatively or positively affect the industry that you might be in right now. Because it becomes a big question of trade-offs and profitability and so on. And that's the end of that presentation. It's pretty much simple and straightforward, but it does show the importance of having data. And I just reduce these and get back to my den. So that was it, folks. I hope that gave you some insight as to how the technology is of such an integral part of supply chain in terms of gathering data and getting sufficient data. And oftentimes we would find collecting data that we didn't even realize or know we should be collecting. And particularly when it comes to behaviors and looking for trends and categories and It's one of my favorite areas of research is grounded theory. So in that area you're looking for, or that methodology, you're looking for patterns, and you might see some patterns or some categories begin to form, and eventually something begins to surface up. But initially, when you start out, you're not quite sure what you actually want until you see the data beginning to form clusters of data, and then we can interact these different clusters, and a picture begins to emerge. But that's essentially the whole concept. It's buzzwords, call it what you will. It's here to stay. That's the important thing about it, and knowing how to have the systems that can gather the data, and knowing that the technology is becoming far more advanced to enable us to get the data and make sense of all of this overwhelming levels and volumes of data and variables and events and so on. Okay, folks, that's it. I'll call a halt on that one, and we'll talk to you later. Cheerio. Bye bye.